This is the first segment of the two-part video where I'm just going to talk about the project goals and architecture and give some introduction to some of the components that are used in this interface. So essentially what I'm trying to do is have a voice-controlled home automation project, just fun for learning. It gives you an opportunity to buy some cool toys and learn some electronics along the way. And so the goal is to eventually have this Echo Dot that's running the Alexa voice recognition system through Amazon, and have it control pretty much everything in the house, entertainment, or even physical things like lights and other devices. So out of the box, it does quite a bit of things, but it's not really that featureful. But Amazon, lucky for us, has exposed an API called the Skills API, and you can essentially teach it new skills. And that just requires some web service being hosted somewhere that can run some of that business logic while you rely on Amazon for the voice recognition. And so basically the components of this project are the Echo Dot, which is this kind of small sister of the larger Echo that has that big whopping subwoofer and speaker. I like this. I mean, this thing was 40-50 bucks on Amazon. It's a steal. I got two of them, one for upstairs, one for downstairs. A few buttons here for audio, so you can increase and lower the volume. And I've got the mute here so that every time I say Alexa, it doesn't trigger right now while I'm showing the video. And so let's just show a little bit about what the Echo can do. I've got it plugged into my laptop. It's connected to Wi-Fi, so it pretty much will work anywhere in the house. So, hey Alexa, how old are you?
I'm 2 in human years, 14 in dog years, and 25 in cat years. I think AI years are marked by nanoseconds, so that makes me like a skrillion.
Yeah, she has her own little interesting sense of humor as you get accustomed to some of her answers. They're pretty interesting. But already comes out of the box with quite a bit of features, interfaces with all kinds of web services and things of that nature. So it has a pretty decent backend. I mean, not super elaborate, but that's what's cool about coding it, right? You can add the functionality. And so in addition to the Echo Dot, I've got the Arduino here, which right now is connected to kind of a basic motherboard or a breadboard that I'm using for prototyping. So I don't have to solder anything until I have a final design. But this is a really, really cool platform. Arduino is essentially an open source hardware platform that allows exposing pins and gives you the compute and memory and all that stuff in a very small, low profile platform that you can interface with all kinds of cool sensors, and they have shields where you can plug in on top of it. That's what these leads are here for, these little headers. They let you connect various shields to add Bluetooth capability, GPS. You can plug in and have humidity sensors and thermostats and all kinds of cool stuff. So right now, basically what I've got is I've got the LEDs for this project, the IR sensors over here, and that's what I use to read some of the sensor information from my remote, so that I can then replicate that through this IR lead. Right now, this breadboard only has, or in this implementation, only has the one IR LED emitter. This is the thing that sends the signal to the actual television, with some resistor here so I don't blow out the LED, and so on and so forth, and power cables and all that. So you can see it's pretty much a prototype right now, but it's a working prototype. If you'll see in segment 2, we'll take it for a spin. A little bit about the Arduino board. Very, very cool board here. You got Ethernet, USB for data over like a jump drive or something like that. You've got a micro USB here for power. This is the large Atheros chipset that runs Linux and has the Wi-Fi. This tiny little, I don't know if you can see, but this tiny little black block here is the actual microcontroller, the ATmega controller. Very, very simplistic, allows access to these pins, and then all the cool stuff is done on the Linux here. And Arduino actually did a really cool library, or build an interface between this microprocessor and the Linux processor, which is a bridge, which I use in my implementation to talk between the two, because the microprocessors can only run, one code at a time, or sketch is what Arduino calls it. And then the web server can actually run on the Linux side and do a lot more things and be multitasking like you would expect Linux to be. So I've got all this stuff plugged in here, right? And I use the remotes using some code, Arduino Sketch, to get all of the IR codes with the IR lead or LED that's going to be transmitting the data. And so this is what it looks like right now. As far as the code goes, it's roughly 130 some lines of code. Very, very simple. Building a server. You can see I've got all the IR signals that I captured from my Samsung sound bar, Samsung TV, the Samsung Sharp codes, and essentially I'm not going to dive deep into this code, but essentially it just sets up a web server. And then I have an Alexa function here that will process data, right? So from an architecture perspective, this is how it works. You've got the Echo Dot that you speak into, so you can tell it to do things like turning on the TV, increasing the volume, so on and so forth. Echo Dot processes my voice, sends it over to Amazon for recognition of what I actually said, because that's why this thing needs to be internet capable. These things are not, the processing for the voice is not done on here. That is a very computationally expensive process, and so you need a lot of servers, especially with the hardware that this thing is built out of. Pretty commodity, you're not going to get much out of it. So the voice is sent over to Amazon servers. That's processed. The recognition is there, or what they call utterances. So when I say like bedroom TV on, or please turn the bedroom TV on, or can you turn the bedroom TV on, these are all synonymous for essentially the same execution, right? And so the Echo Dot's pretty good about that. So when you say things like, can you please tell me what the weather's like today, or what's the weather like today, you're going to get the same response, because it recognizes that in the various utterances that are capable in human speech. So once that voice makes it to Amazon servers, and the Amazon servers recognize what I said, the Echo Dot is actually calling a web service that's running on this Linux component on this Arduino box. And when that particular command comes in, like for example, turn the bedroom TV on, that's actually bridged over to this microprocessor, and then that's where all the cool stuff happens, right? So once I've actually got the business logic taken care of, the physical part takes over. So then recognizing that I want a bedroom TV to turn on, or living room TV to turn on, or bedroom TV volume increase, things like that are all different REST API calls through this web server to the microcontroller. And the microcontroller basically says, I've recognized this, or this call was made to turn on the bedroom TV, and this IR LED emitter will send that signal over to the device that it's pointed at with the right IR code and the frequency. So these are all like 38 kilohertz IR frequency LED emitters, pretty standard, same as the receiver. And IR codes are, for being such a ubiquitous technology, are a real pain in the butt to deal with. I essentially pieced together a bunch of stuff here to get these codes, and finally we're able to get this large list of codes. See, the single line there represents just the signal that the Samsung soundbar receives for power input. And these are all just high-low frequencies. That's essentially how infrared works, is just pulsing at various frequencies. It recognizes that on the receiver end, interprets that as some command like power or volume up or mute or whatnot. And so I've categorized all of these devices into what I need, and starting up the web server and recognize all of these. So you can see that I send various commands based on what the recognition command comes in. So that's essentially it. That's how we get all these things to talk together. Echo Dot over to Amazon, recognizing the voice, sending that command based on the recognition back to my board here at home, running a web service. And again, very, very prototype, end-to-end connectivity works well. You'll see in the second video, I'll show off kind of a demo of how this works. and then eventually, you know, throw on some transistors here and more LEDs to get a little bit more power and get off the breadboard, and essentially have some component that I can solder together and plug directly onto the Arduinos, put a case together, and kind of do the finishing touches. So hope to see where this project takes me. It's a great learning opportunity, and so let's start up the second segment where I'll show you exactly how that works.